Okay, this time I want to find the area under standard normal curve between z equal 1.6 and z equal 1.75. So what I'm going to do is draw the normal curve, like something like that. And then in the middle here, I know that this is going to be a z-value of 0, and the horizontal axis here is going to be z-values. Over to the right, I have positive z-values, and over to the left, I have negative z-values. Now the two z-values I'm using here are 1.6, so I'm going to draw that in, and then up above here I got 1.75, so I'm going to draw that over to the right of 1.6. And the area I want this time is the area between these two z-values, so it's this shaded area right here. Okay, now I know I can't use the table directly to look up this area because the standard normal table just gives me the area from the left-hand side of the curve up to some z-value. But again, I can be a little bit tricky and look up two areas in the table and subtract those to come up with the area that I want right here. So this time what I'm going to do is I'm going to look up the area from the left-hand side all the way up to the upper z-value here, the 1.75. And then I'm going to subtract off the area from the left-hand side here all the way up to the second z-value, this one that's at 1.6. So this is going to be a table lookup of the upper z-value, the highest one, so the one farthest to the right there, 1.75, and then subtract off this area up to the lower z-value. So minus table lookup up to 1.6. And if I subtract those two values, then I should be able to get the area between here like this. So first let's look up the area that goes from the left-hand side of the curve all the way up to 1.75. So if I look up 1.75 in the table, look up 1.7 and go over to the column that says 0.05 in it, I get 0.9599 for that area. So that's the area from the left-hand side here all the way up to this upper endpoint right there. And then I'm going to subtract off the area from the left-hand side up to the lower endpoint over here in the second part of this expression. So over here I'm going to look up the z-value of 1.6 in the table. So I got a 1.6 and it's 1.60. So the second part here is 9452. And I just need to subtract those two to come up with the z-value, or to come up with the area between those two z-values. So when I do that, I get 0.0147. Okay, so that tells me that the area between these two is 0.0147, or if I change this to percents, it's going to be 1.47% of the data underneath that curve. Or if I round this off to the nearest percent, it would be about 1% of the data. So this area right here, even though here's a good example where our picture is a little bit off, but it really only represents about 1% of the data, or about 1.5% of the data.